bombers typically could not maneuver, had to keep going. And by the way, if you noticed, these planes were flying unpressurized, meaning they were open to the air. It was pretty cold, and they were all on oxygen. When they finally got over the target, audio please. They'd open the bomb bay doors. Try to find the target, see the black anti-aircraft fire. They'd line up the target, fly right through the anti-aircraft streams, try not to get blown up, and they couldn't maneuver. And they tried to destroy the target with dump bombs. This was World War II. Now, eventually this will connect with Silicon Valley, though most of you are going, gee, thanks for the World War II story, what are we watching? The interesting part of the story is that the average age of these crews were younger than my students at Stanford. Average age of the crews were 19. Luckily, they did not take advanced math. Because for every 100 bombers on every mission, 4 to 20% wouldn't return. And here was the math challenge for the US and British High Command. The crews had to fly 25 missions to go home. Do the math. We could replace the planes. The Germans were attriting or killing off our crews faster than we could train them. This is the scene, late 1942. British and American High Command say we have to figure out how to either shut down the German air defense system or we have to stop strategic bombing of Germany and leave the Soviet Union by itself. That was unacceptable. This is where it gets interesting for Silicon Valley. Because this is story 2, the development of the electronic shield and something called electronic warfare. The High Command says, let's set up a secret lab at Harvard on the East Coast, and we'll call it the Harvard Radio Research Lab, which you'll hear in a second had nothing to do with Harvard Radio or research, so it was a good code name. And its job really was to understand the radar signals that the Germans had, and then to figure out how to shut it down electronically. And those two fields, signals intelligence and electronic warfare, were born in this lab. And the job of this lab was to reduce the losses to fighters and flak, first by understanding the German air defense system, by inventing an entirely new field, electronics and signals intelligence, and then to electronically or manually jam and confuse the German air defense system. First, we needed to understand how many radars they had, where they were, etc. That's called understanding the order of battle. And then we needed to shut it down, first mechanically, I'll show you how, and then electronically. And by the way, you guys have a year to figure this out. There was no Google. You could not Google German air defense system and get frequencies and pulse rates and whatever. Though that would have been nice. Maybe we could have said, hey, wait a minute, can we develop this? Didn't happen. This was a top secret 800-person lab. The first thing this lab did, along with the British, was to figure out how to jam the anti-aircraft and ground control intercept radar by an interesting notion. Anybody in radar or microwaves here in the room? Yeah. Welcome to the software world. There isn't a hardware person left at Stanford. It turns out, if you cut a piece of aluminum foil to half the wavelength or half the frequency of a radar set, through those pieces of aluminum foil right in front of that radar, the operator would just see noise on their screen. You could confuse a radar by throwing tinfoil right in front of it if it was cut to the right frequency. And some bright guy said, hey, why don't we get a lot of spies out there with backpacks and throw tinfoil in? Someone said, well, I don't think that's going to work. We're going to need 30,000 spies. Why don't we just invade? It doesn't work. Well, someone said, well, why don't we put tinfoil on all the bombers? And when people stopped laughing, someone said, hey, that's not a bad idea. Why don't we try that? And so the first way they tried to shut down the German air defense system was strips of aluminum foil. Each plane had 46,000 packets of tinfoil, about 10 inches long, packaged up. And remember, these planes were unpressurized, so they could open the doors. And they said, you, over there, airman, target, we're being shot at, open the door. And they went, what? You want me to do what? Open the door and dump this stuff out. And they did. They tried it for the first time in July 1943 over a city called Hamburg. Shut down the entire German air defense system. The British used it first, then the Americans. Shut it down, literally. No losses, almost none, to fighters or anti-aircraft guys. And the results to Hamburg were devastating. So these mechanical methods worked great. And by the way, it used 3/4 of all the aluminum foil in the United States. In World War II, people were going, why can't we buy any more? Well, we must be building airplanes out of them. That must be really impressive. And we'd have aluminum drives to get aluminum cans, and people thought we were building like new bombers. We were using it to make chaff. The other way we were doing this was electronically blinding the German radar, and this is where the electronics came in. We jammed all the radars, the early warning radars, the anti-aircraft radars, fighter radars, ground control radars, by building something called a jammer. We weren't too creative with names, so okay, jam it, jammer. And these things would transmit noise on the same frequency as the German radars. We built over 30,000 of these. There were 18 American factories in World War II that worked 24/7 building jammers. Full-time factories did nothing but build these electronic devices, which are then the cutting edge of electronics. I just wanted to set the scene, because now we're going to get to the Silicon Valley past part. This is nice. You now learned something about World War II you never knew or cared to know before you sat here this afternoon. Here's the interesting part. Who ran this most secret lab you never heard of and became the father of electronic warfare in the Cold War for the United States? Who ran the most secret lab that was not only used in World War II, but every technique was used there was used against the Soviets in the Cold War? Remember, this is the Harvard Radio Research Lab, 800 people. You might know this guy's name? Frederick Turman of Stanford. Here's where the Stanford and Silicon Valley connection starts. By the way, when I asked this question in the class, do you remember who started Silicon Valley? Just so you understand the irony, I'm asking the question standing in the Turman Engineering Building. Okay? No one ever knows the answer. Okay? Now, if any of you go there, you'll know. Frederick Turman is one of the fathers of Silicon Valley that you've never heard of. By the way, they're going to tear his building down next year because we're all moving on. Stanford Professor of Engineering, 1926. If he's known for anything, he's known as being the kindly professor who encourages students, Hewitt and Packard, to start a company. In the 1930s, he was kind of wrote this basic textbook for radio engineering, which was the cutting edge of electronics. His textbook was read everywhere in the U.S. Dean of Engineering in 1946, Provost of Stanford in 1955. This brings us to story 3. Turman headed up this secret lab only because of one reason. In World War II, the U.S. government did something that was never done before. They enlisted universities in the war effort, not by drafting scientists, but by putting them to work in specialized labs and letting them stay civilians. And they gave tons of money to universities. $450 million in 1945. MIT got $117 million. Caltech 83. Harvard and Columbia 30. In fact, the amount of money given was kind of proportionate of what the government thought of that particular university's engineering expertise. Stanford got 50 grand. Okay, all right. Next. But they thought one professor stood out among everything at Stanford, and that was Fred Turman. But they said, there's nothing for you to do at Stanford. You're either going to come back east or you're going to sit out the war teaching classes. And so that's why Turman went back east to head the Harvard Radio Research Lab. But when he came back after World War II, he said, we're never going to be screwed again at Stanford. Sorry, but that was his conclusion. We now know something that no other university knows. He said, I personally built the world's leading research center in microwaves and electronics. And he did. and I'm going to build that center again at Stanford University. First thing he does is take 11 of his managers from the Harvard Radio Research Lab and says, hey, you didn't notice, but congratulations, you're now Stanford faculty. Okay, I'll take that. They move to Stanford, and he sets up the Electronic Research Lab for basic and unclassified research in 1946 and gets the U.S. Navy Office of Naval Research, which was the most innovative post-war government agency, to start funding Stanford to solve two military problems, which I'll describe in a second. But by 1950, he drives Stanford's engineering department in microwaves and electronics to the equivalent that people said at the time of the MIT of the West. Now, military had two problems in the Cold War in the 40s and 50s. These jammers needed more power and needed to be frequency agile. World War II, these bombers flew in to Germany in a stream of hundreds at a time. So even though these jammers were very low power, the combined power of all of them was enough to overwhelm the German radars. But if there was ever going to be a war of Soviet Union, our bombers were going to go in one at a time or two at a time. And their jammers had to be strong enough to protect themselves. Two is, new Soviet radars, who was the new Cold War enemy,